y21 is how much? 10. Second row, first column. Okay. Magnitude. Okay. So 10 V2. V1 is just 1 itself. Okay. So this term will be 10 V2. V1 is 1. This is 10. This is unknown. So it will be 10 V2. Now cos. So this is known 0. And this is delta 2 unknown. Okay. This one is 90 degrees. Second row, first column. So what is cos 90 minus theta? It is sin theta. So this whole thing will become sine of. So this term becomes this term. Just I am substituting this. Okay. Come here now. V2, Y22. Y22 is what? 30 magnitude. Okay. So 30 into V2 square. Cos of something plus 90 is what? Cos theta plus 90 is minus 90 also. 90 plus then become minus sign. So this is this. Okay, anyway, this is 0. Okay, this entire term is 0. Entire term is 0. You need to worry about it. This entire term is 0. Okay. Third term. So V3 is 1. It is given to you. If it is 1.5 or something, 1.05 or something, you have to answer it. Okay. V23 is how much? So 20 V2. Then this will become 3 minus 2 and then this will become sine, but then it will be minus. Cos of 90 plus theta is minus sine. Minus 20 sine of. Okay, so I just, that length I just reduced it. Okay. So I just remove this middle. So I got one function like this. V2. I just simplified that. Okay. What is V3? So 1, 1, Y31 is 0. Third row, first column. So this entire term will cancel. Okay. What about this one? Cos term is also 0. Delta 3 minus delta 3 is 0. And then this is 90, cos 90 is 0. Or cos minus 90 also 0. So this term is also 0. So this term goes to 0 and this term also goes to 0. Then I have only this one term. So this is the 20. So 20 into V2. So this will become minus sine of this. So minus 20 V2 sine of delta 2 minus delta 3. Okay. So this I got another function for P. Now for Q2, what is the function for Q2? So there is a overall minus outside. So this is 10, 1, sine something plus 90. So sine theta plus 90 is cos theta. Okay, cos of all of this. So what I will do is, this is 10 V2 cos of okay, this is anyway 0. So cos of minus delta 2, that will be delta 2 itself. Cos of delta 2 itself. Whereas there will be one minus sign. Plus theta. Then minus cos theta. So this is 90 degrees and then this is theta degrees. Okay, there is a vector. Okay, what is the sign of that? Cos theta, plus or minus? Yeah, so because we are interested in this one. Cos theta. If I look at this triangle, cos theta. Sin 90 minus theta is what? So from this I know sin 90 plus theta is cos theta. So here also I am only interested in this one. So if I look at only this triangle, it is cos theta. Anyway. So cos of minus delta 2, that is delta 2. So cos of minus theta is theta. What about this? This is 0, sin 90 is 1, or sin minus 90 is minus 1. So this whole thing is minus. Y22 is 30. So minus 30 V2 square. That's all. This V2 square minus this is 30 and minus is because of this. See, theta 22 is what? Angle of this. Minus j is minus 90 degrees. Okay. So that is this term. And what about this term? So cos of 3 minus 2, and then this will be third term. So 20 V2, then cos of okay, and this will be plus. But remember, there is a minus outside. Okay. So what I did is from this I reduced to this. So what is the next step? So next step is jacobian. Somebody mentioned. Right. So let's write the jacobian. Okay. So now I'll remove this lower part. Hopefully there are no errors in it. So first I will write the jacobian in this form. Okay. So delta 2, rho delta 3, rho there is the first row of jacobian. Differentiate the first function with the first variable, second variable, and third variable. Differentiate the second function with first variable, second variable, and with third variable. Then this is row. So with no V. Okay. So this is my J. Okay. So let's write it down. First term. So take this function, differentiate with delta 2. So what is the differentiation of this with delta 2? So 10 V2 differentiation of sin is cos. 10 V2 cos delta 2. 10 V2 cos delta 2. This is over. Differentiation of delta 2 again. So this will become plus because there is a minus sign. So plus 20 V2 cos delta minus delta 2. Okay. So this is first term of my jacobian matrix. What is the second term of jacobian matrix? Differentiate this one with 3. So this one. So this term is constant. So 0. This term will be minus 20 V2 cos of delta 3 minus delta 2. So this is my second term of jacobian matrix. So differentiate with V2, the third one. So just V2 will be removed. So I can write it into 10 sin delta 2 minus 20 sin delta 3 minus delta 2. So this is my first row. Okay, what is the second row? So this differentiate this with delta 2. So just same thing with cos. That's all. No change. So minus 20 V2 cos of delta 2 minus delta 3. Okay, that is this one. Next one is differentiate with delta 3. Same thing, just with the sign change. Okay, this will be plus v2 cos delta 2 minus delta 3. And then differentiate this with v2. So just remove the v2, you will write the rest of the thing. So it is minus 20 sin delta 2 minus delta 3. So this is my second row. Let's look at the third row. So differentiate with this delta 2. So there is a minus overall. So I put a minus overall. 10 v2 sin delta 2 but with minus. Because differentiation of cos is minus sign. Okay. 10 v2 sin delta 2 with a minus inside. That is for this term. What about this term? 30 v2 square. This term is constant because I am differentiating with delta 2. And what about this term? 20 v2 sin, but then the minus will get cancelled. So 20 v2 sin delta 3 minus delta 2. Okay. So minus will get cancelled, so I am just giving plus inside. So there is a minus outside. Okay. So this is term. Now differentiate again with delta 3. This is constant, this is constant. This one will come with minus sign, but there is outside minus sign, so they will come. So I'll just write this one. 20 v2 sin of delta 3 minus delta 2. Now finally differentiate this with v2. So this will be 10 cos delta 2. So there is a minus outside. 10 cos delta 2. Okay, minus 60 v2 plus 20 cos of delta 3 minus delta 2. Then the minus outside. This is my equation. So I think now all the groundwork is done. So what is the next step? Next step is the Newton-Raphson. Okay. So I'll keep it like this, and then maybe I'll start from this down. So initial case delta 2, delta 3, v. So I'll start with the initial case. Okay. So what is the correction? So this is the 0, 0, 0. Okay. What is delta 2, delta 3, v2, 1, 1, 1? Do the next iteration. What I should do? I'll just take the same thing. 0, 0, 1. Okay. Minus. Or actually I should say plus j inverse. Minus 0.5, 0.3, minus 0.3 minus, you have to substitute calculated values. Okay. So, what is the calculated value that I am writing here? V3, Q3, calculated value. Okay. Just look here. The solution, you substitute in this. Okay. V2 is 1. Okay, V2 of 0 is 1. So 10 into 1. And then what is sine of delta 2? Delta 2 is 0. Sine 0 is 0, so this whole term is 0. Then this one is also 0 because of sine. Okay, so the calculated value of V2 is 0. But what is the expected value of V2? Calculated value is 0, expected value is this one, minus 0.5. Therefore, the error is calculated minus expected plus 0.5 the error. Okay, so that error term will come here. So that's That's why this minus 0.5 is there, because we have taken that minus inside. What is the P3 value? Again, these two are zeros. So sine 0 is 0, so this entire thing is 0. So this is also 0. And Q3 calculated is also 0, or is it something? V2 is 1, cos of delta 2 is 1, so cos 0 is 1, so this is 10 minus 30 plus 20. So 10 minus 30 plus 20 is again 0. So this whole thing is also 0. So my error vector is this itself. So what is the, this is Jacobian inverse. Okay. So what is the, so I have taken the minus inside. If this was minus, then this side will reverse. So what is the, let's calculate this now. So what is my J? It's also very easy. Look here. So this is 1, cos of delta 2 is 1, V2 is 1, so therefore this is 10. Okay. 10. So this one, minus 20, 1. So minus 20. Sign is there, therefore this is 0. So this one, minus 20. 1 plus 20. 1, because sign is there, it is 0. So this one, sign is there, so it is 0. It's all easy because our initial solution we are starting with 0, 0. So if this is like 2 degrees and this is like 3 degrees, then it will become very difficult and solve it using computers. So what about this one? Also 0. What about this one? 10 minus 60 plus 20. So 10 minus 60 plus 20. 30 minus 60 minus 30 for outside there is a minus 30 for plus 30. Okay. So notice that these two sides are zeros. That has some importance. We'll look at that later. What is J inverse? What is J inverse? So if I give you this matrix and ask you what is J inverse, how will you do it? Adjoint of J by J, but then we can do it even better because this is 2 by 2 matrix and these are zeros not interacting with the third variable. Only 2 variables are interacting with each other. I can invert this 2 by 2 matrix, put it here. I can invert this 30, 1 by 30, I can put it here. So that is also okay. So this is 1 by 30. What is 1 by 30? 0.033. Okay. What is it? One is 30. Yeah, I forgot this term. Okay, this term is also. So now, how do you find invert? So AD minus BC, 600 minus 400. So 1 by 200, AD minus BC, minus 100. That means it is 200. So 20 by 200. So 1 by 10. So it is 0.1. That is B. Then minus B. So 0.1. This will be 0.1. Then 30 will come here. 30 by 20. So 30 by 200. 30 by 200. By 2 is 1.5. 0.15. See, without calculator, I inverted a 3 by 3 matrix. So now what this J inverse will go? This J inverse will go here, multiply it with this, and then that will correct our deltas. Okay. So do that. So this J inverse will go here. So let me rewrite that. 0.1, 0.1, 0.1, 0.1, one into this, this one into this.
After jacobian inverse, this is function of 1, you put x or minus z. If you put that, it becomes 0. You are taking 0.5.
We should get the error actually. So if we substitute, we are getting zeros. But then okay, earlier we have taken f1 is nothing but x0, y0, z0. Expected was always 0. But here we have some expected values. So the right hand side is not 0 in this case. Right hand side will appear in our. Third one. See, okay, initially we started like this, right? X cube minus 6x square plus 9x minus 4 equal to 0. Okay, we started like this initially. Suppose if I put this minus 4 on the other side, okay, and then say that expected value is 4. Okay, so what is the error? It is something like that. Because in our case, we are getting like this. P2 is equal to some large x. So the right hand side, or in this case the left hand side, is not 0. So P2 value should be this one, minus 0.5. So that way it is slightly different. So let me think about it. Correction is expected minus calculated. So this is expected, this is calculated. Expected minus calculated is correction. Correction is J equals, okay, so this will be minus. Okay, so that should be minus. So if you calculate it, what happens now? Or should it be plus?
You put minus there, then you get 0.5.
Then the earlier was correct. That's what I did. Earlier was correct.
Because sir, you are taking power and
the way I decide this is, I already know that delta 2 is negative. I already know that. Because power has to flow from bus 1 to bus 2. Therefore, delta 2 has to be negative. So as to get the negative, I will choose the sign accordingly. So what is the, just calculate the next step. See, this is minus 0.5 plus 0.3, negative minus 0.2. 0.01 plus minus 0.2. Then this is 0.2. So minus 0.02. Okay. What about this? I think I did calculate it. And then 0.05. And this one is 0.0. Minus sign. Okay, so now look here. This is an important observation. So what is my final value of delta 2? So 0 minus this one. So delta 2 is minus 0.02 radians. Okay, minus 0.02 radians means you will get some value in degrees, which is negative. And then delta 3 is minus 0.005. And then V2 is 0.99. Okay, so slightly the voltage 2 is reducing, and the delta 3 is also negative, but not so much negative compared to delta 2. So between 3 and 2, the power flow will be from bus 3 to bus 2. Between 1 and 2, the power flow will be from bus 1 to bus 2. So both are generating their power. So what is the next step? This solution will go here in this place, and then this solution will come here, and then you will calculate this, and then this solution again will go into this, and then you will calculate j, and then you will invert that j, and that inverted j will go here. So, and then this one is same. So you have new value of this, new value of this, and new value of this. Then again you will get a second iteration of delta to delta. Then that will again you will put it here, and then same thing, you will calculate this, substitute in this, calculate this, invert it, and then again get it back, and so on. Like that you do some iterations. After a while you will notice that delta 2 value does not change much. So when that change is not much, then maybe the time becomes short. So this is about 3 by 3 case. If you have a larger power system, the same thing, the jacobian matrix will be larger every time. So some people said, let's do like this. Instead of inverting this every time, so because inverting a matrix is again, it will take computation time. Okay. So what they do is, if I am running this matrix, iterations, like 20 iterations, then every 5 iterations, I will invert the matrix. Otherwise, I will use the same old matrix. So as a result, the number of iterations might increase, but then the amount of calculations will reduce. So some people do like that. So all these things now, given the overall idea, how you are writing the code for that. So about that Newton-Raphson method. So I will just show an example. Like, we will not see all these calculations. All of this will happen in the background. I just show an example. So just again notice here, I have opened the MATLAB, and then you can see the MATLAB comment box. So I'll just list out the files. So there are some files like this. So what I have done previously is this is the folder which I downloaded from internet. The folder name is Math Power 3.0.0. Just stop your discussion for now. I know it is exciting, but then just get so because they are discussing about that topic. So 3. So this is the Math Power software which I downloaded from internet. It's nothing, just a folder with this file. So you can open and look at this files. So these are all your power system studies kind of related files. For example, you can see one program called Gauss sphere. So this program will do Gauss-Seidel method of power flow calculation. So if you open this file, so this file, let's try open it. So today, whatever I talked on the board behind, same thing is the program. So it's all. I think this is calling somebody. This is like by this file it will have more details. Okay, my objective is not to go into the program. My objective is to just show how to run that. Okay, I'll open a data file. It's 9.s. So there are a lot of cases. You can see case 57. There are 57 buses in that system. You can see case 300. So this is a very large power network with 300 buses. Okay. So I am opening case 9. So when you open case 9, I have this bus data. Okay. So 1, 2, 3, 4, 9 buses are there. Okay. So bus number 1 type is 3. That means 3 is the symbol for slack bus. Okay. The first bus is slack bus. Then because the PD power demand is not there. Whereas these other are all load buses. Even if there is a zero demand, it's a load bus. So how many? Now I'll ask you the question: how many state variables? 9 buses, therefore 18 state variables. Out of 18 state variables, how many are known? How many are unknown? So if you get this one, you know both voltage and angle, slack bus. If you look at 2 and 3, you know voltage, but you don't know the deltas. So two are the unknown. Whereas the remaining 6 buses, 6 is 12 unknown. So 12 plus 2, 14. So there are 14 unknowns. So your size of your jacobian matrix will be 14 by 14. And the branches. So 1 to 4 there is a branch. So let me just quickly draw the network also. So I 1 and this is 4. Okay, 1 to 4 there is a branch. 4 to 5. Okay, so let me put here 5. Then 5 to 6, 3 to 6. Okay. And then again 6 to 7, 7 to 8, 8 to 2. So 7, 7 to 8, and again 8 to 2. Then 8 to 9 and 9 to 4. So 8 to 9 and then 9 to 4. So this kind of circuit is there. 1, 2, 3. So we know that 1 is a slack bus. So there is a slack bus here. We know that 3 is a generator bus. 2 is also a generator bus. What I am doing, I generate power at 2, I generate power at 3, and then I generate power at 1, and then that is the circuit or the network, and then this is the network. 4, 5, 6, 7, 8, 9. That is the circuit. Where are the loads? So if I go back to the load data, so 90 megawatt and 30 MVAR are at bus 5. So at bus 5 there is a load. And at 7 there is a load. Then at 9 there is a load. Is that so? So this is the problem that we are here. So given these generations and loads, how the power flow happens and all. So let's solve it. So for solving it, I go to MATLAB and then simply RUNB to run power flow and case 9. So I got a solution. So I told you like there are 14 state variables, jacobian matrix is 14 by 14. All that things happen. So if I go up, so Newton's power flow converged in 4 iterations. So that means they used the Newton's method and then they converged it in 4 iterations. So 4 times the 14 by 14 matrix was there, they inverted it. All that things happened in just milliseconds. Again, so I will run the command again. That's all. So it just did that calculation and then the results. So what are the results? We go up. So this is just statistics. 9 generators are there, 9 buses are there, 3 generators are there, 3 loads are there. All this is just about that. Interesting part of the result is here. So write down the results. So what is happening at bus 3? 85 and then minus 3615. So here I am generating 85. I'll just write the active power. Reactive power I'll not write. So 85 is generated at 3 and then 163 is generated. Then at 1, 71.95. So 71.95. So these are the angles. Okay. Since this is a slack bus, the angle here is 0. What is the angle at bus 4? Minus 2.40. What is the angle at bus 5? 1.02. What is the angle at bus 6? Plus 1.22. So that means what? So power flow will be from 6 to 5, like this, and here the power flow will be from 4 to 5. So whatever is consumed at 5, these two together will add up to the demand at 5. So how much is the power demand at 5? 90 plus J30. Okay, so 90 megawatt is the load here. Okay, how is this 90 megawatt? So I want to look at the branch data below. So if you go down, so from 4 to 5, look here. From 4 to 5, the power flow is 30.7. So 30.7 is coming from here. Then from 6 to 5, or 5 to 6 is the opposite. So 60.4, whatever that is coming from this side. So 30 plus 60 will be 90, but 0.7.4 of the losses will be 90. So they have nicely written this program so that you can just change the data, run the program, and then resolve it. You will get all the what are the power flows and what are the. So if I instead of 90, if I change the data, go back. Instead of 90, if I give 140, okay. The power demand at bus 5 increased to 140. Sales is 5. Go back to random and then run the. Now you can see the power demand here is 140 and then the voltage is maybe this one. The angle is even lesser. So earlier the angle was how much? So on the board you can see -4, but now the angle is -8. So even the demand is. What about the power? This one close. 4 to 5 is 74.96. Then 6 to 5 is 66. So the addition of these two, 74 plus 66 will be 140. So that way you can change your data and then rerun the program and find the. So this is all what is happening with the same solution. You can also get Gauss-Seidel method also. I changed the command a little slightly different command. So there is like choice of power flow algorithm. I just put 4 here. If I put 4, it will choose Gauss-Seidel method. Okay. So Gauss-Seidel method you have seen couple of lectures. Okay. So how much time did it take? I just went and just that's all Gauss-Seidel method. But how many iterations did the Gauss-Seidel method? Or can check that. 181 iterations. So this Gauss-Seidel method, we have done 1 iteration or 2 iterations. So for this 9-bus system, it is taking that many iterations too. And then you got the more or less you got the same solution. Go down. So minus 8.13, whereas for Newton-Raphson it was very slightly different, minus 8.3. There are always slight difference in these methods. So, maybe part of the study that all was study. Given the generation and load, how the power distributes in your circuit, which line carries how much power. And this program is all available. So again, if I open one is gross power loss. Okay. If you remember sometime back we tried to do. So if you look at this one, okay. So what you are doing is conjugate of S divided by B conjugate. So you remember this one, and then kth row of fibers multiplied by the voltage vector. So that's what we used to do. And whole divided by YKK. So it's just exactly what we discussed in class. Same thing. This is done for PQ bus. Whereas for PQ bus means load bus. Okay. Whereas for generator bus, because Q is unknown, you have to solve Q and then substitute it back. So that's what it is doing in PV buses. So first the S is calculated, that means the Q is calculated. But this side and this side is same. But just one step extra will come. I hope you are trying to recollect all the parts that we see. Now, the mismatch is calculated and then whether it is converged or not. Converged means how many per printed times. So I think I'll stop here. We can continue with the next.
So just one doubt, like
I meant load is 0.5, therefore I wrote P2 is minus. I considered it